We need to hear your voice.
Okay,
Our
thank you.
ears are really, we are getting this thing.
Okay. How is our Venkat? Venkat is there on the call?
Yeah, he's there.
Right. Yogesh, my friend. Mm,
Hello.
Lakshmi. Yeah. Hi.
What are you doing, Uma?
Yeah, now it is okay, Yogesh. Okay. Venkat, thank you.
I think you are working too much, I think.
Ah, yes, yes.
In fact, this 1.5 years is a big relief to me, to be frank. But even we are not getting that relief also. Okay, no problem. Yeah, let me jump start into this thing. However, our language is this, na? Definitely we'll discuss. And coming to one more exciting journey, friend. This is the probability. Uh, Probably, so which is not a separate aspect, friends. Actually, that's what I post fixed with stats. And in case of the statistics, there is one kind of inferential and as well as the descriptive statistics kind of things. Uh, Especially in the descriptive statistics, we have studied some central tendencies and thereafter dispersion or else spread of the corresponding data, and finally the shapes. Like that, we have seen three aspects. So central tendency, shapes, and as well as dispersion. Okay, like that we are having some three different genres. Okay, again in central tendency, we studied some of the aspects like mean, mode, median. Okay, this is one of the interesting things we have seen. And in case of the shape, we have seen skewness
Yes.
and kurtosis, like the shapes, which is they are trying to tell some kind of the story related to the appropriate data. In case of the dispersion, we have seen various things, friends, like sometimes range, sometimes quartile, and percentile,
Percentile,
variance,
variance,
uh,
covariance.
covariance, standard deviation.
Standard deviation,
Any other friends? Correlation. Okay, our latest
correlation.
latest aspect. Okay, so these things we have studied and we enjoyed a lot because the connect is there. But here the friends probability, suppose possibilities, like so suppose if I am asking Suresh, uh, what is the possibility of learning through TensorFlow with our knowledge? Maybe he is knowing me from past 10 years, assume that, and he knows all my interest and research areas. And one fine day in the discussion, just I have put across like, so just I want to discuss something, Suresh. I want to move from this a normal implementation of the Python. So I want to be into TensorFlow or Keras kind of aspects. Then you can say, Uma, don't go that because your thing is a bit interest. You are interested in research orientation and of course development kind of thing. TensorFlow is a framework, so and which is typically having the deep learning and all. So I don't think you may not get much exposure as per your potential. I'm saying like that he can guide me. And if Venkat is asking Suresh, maybe Venkat is the background of manufacturing, and rather he is rather interested in research or development. He want to make use of some conventions of the predefined functionalities with the framework kind of the activities, and he want to get into this genre without any much coding. Then definitely Suresh suggests to Venkat, yes Venkat, you can based on your interest and profile, definitely you are having extensive feature and as well as all those things, if you could select TensorFlow and Keras. See, we are not thinking about the technology or outcome, friends. We are thinking about the person's capabilities, and based on his interest we are saying the possibilities. Exactly, the probability, so what is the advantage of doing things, friends? Probability, so which is giving some kind of the possibility. And another question is how it is distinct with descriptive or inferential. Can I say my probability as the inferential statistic? Can I?
To an extent, yes.
Yeah.
To an extent, yes. That means, friends, There is no part is also there. Na? That means but we cannot say completely as yes, because if I am saying inferential stat, that means after getting the outcome, maybe I'm discussing and with my team members and subject matter expert and whoever. Okay, so just we are making use of that convention. Okay, this is the outcome, and this I can infer based on the existing things. Whereas description, there is nothing to do with your storytelling. Descriptive, I cannot change the experience of the Suresh, and I cannot change the qualification of the Suresh. These are all the descriptions. Inference in the sense how good he is in the team, how innovative he is in the team. So these things are nothing but the inferential, because after seeing or after observing, your manager can give you the all these qualities, friends. How good he is, in what way he plays with the team, and how best he is innovative. All these things are very nice. And now, if you observe, there is one more genre. Actually, this is the first one, friends. Experience qualification cannot change, cannot be changed. This is our descriptive statistics. And inferential, friends, just based on his capabilities, and we can assign, or we can exploit what exactly he can do. These are all the inferential kind of thing. Apart from that, guys, just we're having one more thing: the possibilities. Okay, or else I can say the chances of happening. Okay, so now tell me, friends, what is the use of going into this genre? We are pretty happy with inferential and descriptive, and some members, for some members, even though they are interested in data science, but at the moment, if I'm wording this probability, uh, maybe they are not comfort by listening to this statement. Of course, I will clarify that by the end of the session. Definitely, you love to do the probability kind of aspects which are strictly related to our data science or machine learning genre. That will have a nice journey, no doubt about that. But out of curiosity and to take it from you, because I always love to listen from learners and friends like you. In that particular case, friends, can someone help me to get the gist of this? What is the what that we are going to get if we are knowing chances of happening, or the possibilities, like, friends? Yeah.
Based on this, they can see whether they can use particular data. Like if it is a marketing person, if there are chances of that thing happening, then they can work on that. Otherwise, if the chances are very less, then they may go for another one. Or might be it can be anything like positive or negative.
Very good.
If possibility of getting the things, whether that works out, then they'll implement it. Otherwise, they will go with some other alternative. So they can, so before starting anything, probability will really help them whether they to make their decision.
Excellent. Because nicely, see, always Venkat, I love to hear from Venkat, is because he always relates the real things in the simplest way. That is his capability. Like, if you are referring again, yes, usage of the data, whatever the data we are having, whatever the things we are having in the hand, we are going to think about the possibility, friends. And maybe our friend has given such a moderate example and modesty kind of thing. I'll give you this example. So just I'm going through some news, and today there is a possibility of 90% of rain. Okay, so 90% of the possibility of rain is there. So tomorrow I'm having some kind of work. Okay, I'm having some kind of work. Then if that work is really important, really urgent or important, then I should plan accordingly. Though rain hits the city, which I am going to have some kind of the client meeting manually offline. So in that particular case, friend, just accordingly I have to plan. Suppose if that particular work is maybe not urgent, it's not that much urgent. Only the thing is I want to purchase one textbook, and rather going with Amazon and all, I love to go and manually see the other information and different kinds of the books, then I can postpone that. See friends, here the one simple example. See the rain, 90% of the chances are there. So why simply going and facing some kind of the disturbance? If it is definitely urgent, maybe the client call or we are going to get some kind of the project, then of course accordingly I can plan. Maybe some I can carry some umbrella or whatever the means, because I have to do the task based on this thing, because possibility of rain is 90%, not 50 or 60. And if it is not urgent, accordingly I can plan. In typical human behavior, as our friend Venkat says like this, the chances of happening and all. Can someone add one more thing? This is a too simple example. This is a moderately good example. And any other, Suresh, I want to hear from you. Suresh or Nilima.
The same what Venkata said. Actually, in a history data from the past years, when the sale predictions we are putting on the on your system. Now, once this year, when you're going with all your measures and everything on the model, you can not predict, you can the probability, you can put it in a way like this can be mostly of 80% to 90% of it will go like this. The shape may be like this.
The expectation may be like this.
The expectation may be like this.
Yeah, you used one word, Suresh. Not prediction. Why you have used that word? I want to hear from you. Why you have not? Why you have used?
Prediction is something very. Uh, uh, I don't say the prediction. How do you say? Like is a strong word actually. The
Yeah, yeah.
probability is where it is yes or no.
No.
It is in the middle, like in a cat in the middle and jumping like on the wall. It may be
Suresh,
this, it may be this.
exactly. You are having strong desire of using this word. You are not revealing that. I want that answer, because that is definitely a lot more to consolidate to other members also. I know you got the gist of probability, and you have used intentionally this word, not prediction. You need to talk on the lines, friends, right? Because you are knowing that answer, and I will give some 1 or 2 minutes time, Suresh, because that is definitely and badly required for all the other members also to understand. You know that. Okay, why I am repeating? Not prediction, you have used intentionally, and I really admired. Why probability is not a prediction? You just you take your time, 2 minutes, and you come up with your own analogy. Always I to enter these kind of critical things, I always bank on your thought process and explanations. Now again I got the chance, maybe third or fourth time this I'm using your support. Can you yeah,
Just give me a minute. Let me just think it out.
yeah. So
Uh,
or else we'll take time, no problem. In between I will
yeah,
introduce,
you take,
and whenever you
keep on.
yeah, yeah, you work it out,
Let me frame
Suresh.
it.
Yeah, yeah, just to frame, and if you could give some example, that is perfectly all right, Suresh. Okay, guys.
Yes.
Now, hope with these kind of things, we are coming to the conclusion that probability is something for us, definitely, because we need to study this aspect based on the examples. And now let us introduce some kind of the terminology, because how we are learning the aspects is like for starting from our beginning of the machine learning sessions, just there are certain aspects, so basically if you are observing what exactly the kind of requirements we are seeing and the kind of understanding we are going to pose related to our probability is, just I am going to introduce some 3 different terms in the landscape of the probability. Just have a look on these, friends, which are very simple, just but whereas in case of the statistics, these terms are pretty easy, like regression and all those kind of statistical aspects. But whereas if you are making use of the conventions, those conventions are a bit distinct in case of the prediction probability. Okay, now you have a look on this. Just there is a first word actually, which is experiment. If I'm looking at this particular model of the probability, So just if I am making use of, if I'm trying to understand what exactly this is the uncertain situation which could have multiple outcomes. Observe here, friends. Situation is uncertain. Up to now, in case of the statistic, we have observed the certainty. Yes, there is a standard situation, and we are making use of that particular situation, and we are coming to some kind of a conclusion, which would have multiple outcomes. That means maybe whether play is there or not. If you observe, friends, in case of the decision tree also, we have used that one tennis play example, something like that. So not only here, the kind of outcome may be different genre, friends. We may get the chance of associating with some of the clients, because client expectations are more, and we are not having the proper resources in our team. So maybe we can recruit, and even after recruiting or recruiting also, if you are not getting the business, then what should we do? There are certain aspects. So that means the situation is uncertain, and the outcomes also distinct, friends, which could have multiple outcomes, is the basically known as the experiment. So tossing of a coin or business deal, these are all some kind of the examples, whether it rains on a daily basis. Okay, so like from 24th to 29 we have planned for holiday, because our company, after because it has recently completed 40th anniversary, as a token of love, our CEO offered us 5 days leave, continuous leave, you can put, take a break kind of thing. And we thought of planning these 5 days effectively, going to holiday or some kind of the trip. But unfortunately, it's a rainy season like this, and maybe we need to face some kind of the situation where there is a chance of raining. And in that particular case, if you are observing the outcome, maybe, friends, outcome is always based on the single trial in the sense we are having these 5 days in our hand. I cannot wait 15 days to take the decision, because I have to plan accordingly. Tomorrow is 24, up to 29th I'm having these holidays in my hand. uh, then definitely I have to take the decision. So this is a single trial kind of thing. And the example on the same lines, if it rains today, the outcome of today's trail from experiment is it rained. Can someone add some point to this thing, friends? How can I say the outcome and experiment differentiation?
Outcome is the occurrence.
Proof or occurrence. Very good. Excellent.
And like that occurred. That's
if it is occurring, then I can say that whether the probability is true or false, whether it has happened or not. Result of experiment. Very good, Lakshmi. You are also nice. You are having that perfect thought process. Always project the things in a simplest way and fine-tuned way. Okay. Now, if you see the next option, friend, event. If you are observing, the word experiment is uncertain, of course. Experiment is uncertain, but outcome is a certain thing, friend. Actually, if you see the proof or occurrence, as our friend told, if it rains today, that means as per our analogy in the experiment, there is a possibility of raining. And if it is raining today, the outcome of today's trail from experiment is it rained. It rained. Next important thing is event, is one or two outcomes from an experiment. Maybe, sometimes it rained is one of the possible event for the experiment. Maybe one or two kind of the outcomes. Okay, rained or not rained. So these are all the kind of things as the event. So experiment is one uncertain situation which may be having multiple outcomes, because at the framing of that particular experiment, you may be having that kind of dilemma, because it all uncertain. And second important thing is outcome is something which is of a single trial. And next important thing is event, is one or two outcomes from an experiment. It is, if it is rained, then is one of the possible event for the experiment. Okay, now how can we frame, friends, in a single statement? If I am asking you, you can use experiment, outcome and event to come up with some kind of the understanding. Then how can you say?
Can I interrupt you? If
Please.
this is, can you just correct me if this is correct? If we have to pick a card out of pack of 52 cards, okay?
Very good.
That is the experiment.
Ah.
And the chances of getting an spade is an outcome. I want a spade. So that is an outcome. And events are something like I can get a spade, I can get, I do not know. What are all the things? There are four
Spade
shapes.
is, maybe
the art.
Suresh is knowing better than us. And there is one consultation is there, Suresh. While we are learning also in our engineering days and all, they used to say, if you know playing cards, then you know the probability better than us.
Probability really good in playing cards. Yes, 100%. 100%.
Because friends, I'm not taking the example of this thing, of course, but we have taken some other, but that is fact, because we're having some 52 cards and ace and as well as the spade and king, queen, kind of main things are there, majority of the things, and a deck of some cards and with these kind of thing. And as our Venkat referred, out of those particular thing, chance of getting the spade, chance of getting us, these kind of things definitely gives us the understanding of, okay, what is the possibility and how many members are going to get the show, or maybe those kind of grounds you can think through, friends. Okay, maybe these 52 or 13 or standard in number, but however the probability greatly helps us to understand the analogy behind this card playing also, friends. That is also one of the important aspect. Now conclusion, Venkat, in that case. Oh, you started with 52 card.
Is an event, because I can get that 4 shapes out of that spade and
show is the outcome, 1 or 2 outcomes kind of thing. Okay. Yeah. Experiment.
According to me, Uma, the prediction is nothing but it's a gunshot, sure thing. When you're predicting something, means yes, it is going to happen. But in the probability, that is not going to, there is a 50-50 chance in the probability. It's not predictable. But there is, I have done in, I think, 25 years back in engineering.
Okay.
We have done that. There is something called as a predictable probability. The probability is also predictable. I'm not able to remember that thing. This question I've asked my son also when he was doing in 10th class. He said, "Dad, don't ask me all this stupid questions. Predictable probability." I don't know. I think there is people also use predictable probability.
Yeah, maybe all these practitioners of this what you say stock market analysis and all, they helps us to understand the of course. Even though it is uncertain, but they predicts very 90% of the cases they predicts well, Suresh. Yeah, maybe we can frame like this. The
prediction actually goes with all the calculations, Uma. The 100% calculated value, then 100%, then you can definitely say that, you can definitely predict that this is going to happen. Because you have all the data, you have all the calculations in front of you, and you have done everything in front of you. Then you can predict it. But in a probability, even though you have done calculations, still you have a doubt of a question mark whether this will going to happen or not. Now, suppose if you take a rain part, you say that there may be a rain tomorrow. There will be a rain tomorrow. How they are predicting that is because of all the values what they got from the sensors and everything satellite. They may get a rain, but if some of the northwest or some wind comes on and it takes away the clouds, then there will not be any rain. So the probability, you don't know. Even the prediction will go wrong if something happens.
Exactly.
So that we cannot do that. But prediction means 100%. That's not. But your value will be close to 90, 97, 98% the value will be correct when you predict it.
Exactly. Yeah.
But probability you don't. Probability is like 50-50.
Correct.
That's
Correct.
what my idea is. My
And
intention of that non-predictable.
non-predictable, and yeah, exactly, Suresh. I'm with you because the moment if I am saying the predictions and all, as our friend rightly said, calculations would be there, and based on the calculations, we are going to play with the data, and we are coming up with some kind of point where these are all the predictions related to my test data and as well as the my training data. But whereas if I'm talking about the probability, friends, though perfect data we are having and all the environmental parameters we are having, but still, okay, there are some kind of things which are not in our hand, friends. Maybe sometimes, though we are all confident, and even political parties also, or exit polls also, they just give the possibility, not prediction. Actually, though they are having some 20 or 30 years of the experience in the industry of uh, explaining these particular exit polls and all, but still some possibility. What they will say is from 21 to 30 seats they can get, from 15 to 20 the seats they may get. That variation is there, no? That is the benefit of doubt. Okay, but in case of the prediction or in case of the descriptive statistics and inferential, we are not floating anything, friends. I cannot say my model might be 95 to 98. There is no such thing is required. I can say either 95 or 96 or 97, like that it goes. That means we are not using any range, or we are not using any possibility kind of thing. Definitely we are saying this is the model. On top of this particular data set, we are projecting these kind of the aspects. Okay, so that is the basis related to our probability understanding. Now coming to the point, what exactly the probability? Because so far we have seen what is the kind of experiment, and what do you mean by the outcome, what is the use of the, what is the event actually. Now if you observe this point, friends, probability is the measure of how likely an event occurs. Okay, so may or may not, that is one thing. And if I want to consolidate these kind of aspects, how likely, okay, this particular probability helps us, okay, or event occurring. Now what we are saying is probability of this particular experiment is number of outcomes and number of possible outcomes. So a number of outcomes in E and the number of possible outcomes can be known as the probability. So out of that particular total possibilities and the number of outcomes. Suppose I'm saying this thing, friends, you can say this answer. Suresh is having 3 interviews, Accenture, TCS, Infosys, and he has done all the 5 levels of the interviews in each thing. And if I am asking him, like we're having 3 companies in your hand, and of course, if you clear all the 3 levels of the interviews, total 3, you have completed 3, so 1. And in another case, whether you are opting these companies or not, he is saying surprisingly 0. No, I am not opting any company. Probability is 0 because he is having offer in Amazon. Okay, already he got the offer and he fixed it. But as those are in line with those things are in line, obviously he is not accepting that particular offer. Okay, but he want to clear those rounds for the sake of checking, and or maybe he is very much interested to have the consultant kind of aspects out of his experience. Reasons might be various. Now see here, if I'm what I'm saying here is though the possibilities are there here with multiple companies, that 3 remain same, friends. So whether he is going to join or not join, or only the option, can I have any in between, friends?
No.
No. So that means 0
Or 1.
That's all. So don't say that what is the probability 3.3 or 2.7. Then you will be caught, friends, easily. If any data science interview, maybe some members who are having a strong stat background, if they want to grill you, by just observing your way of explaining the things on the rounds of statistics. And if they sense this guy is not having some essence of this probability or descriptive statistics, they may ask you the little twist in this case. What is the range of probability and what is your expectation? Suppose if I'm saying 3.5, what do you explain? Like that they may ask friends. So just to observe that whatever the problem definition we're having, so just it is lying.
Also, you can explain the same thing of what Venkat has told.
Ah,
52 cards, spades means it will come by 13 by 52.
1 by
Venkat,
4.
you got it?
Yeah.
And if you say that, how many aces or kings, then it will come accordingly.
Exactly.
Because,
Correct. See,
It again,
here,
it is
what is
special
this
case.
13? What is this 13?
all the spades.
All the
13 cards of
spades.
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 Yeah,
These are number of cards, all the cards.
all the cards.
Okay. All the cards, out of those cards, we're having some specific category, that is 13. Okay, so like that you can see the possibility of 0, 1 kind of the appearance. Never say 1.5 or 2 or 3 kind of thing. Never happened, friend. Probability means you should talk in terms of 0 or 0 point something or up to 1. There is a chance. 1 means complete. Okay, so that all the 3 he has cleared all the 5 levels of the rounds and that is done. But whereas at the moment he is opting, he has never opted anything. He has not opted anything, so it becomes 0. Maybe he's having another offer in his hand. Okay, so like that, if I'm referencing, okay, so suppose the rain example, if I'm taking, friends, if there is a chance of 60% that it will rain, then what is the probability, friends? So 60% of the
0.6.
very
0.6.
how do you say that?
100%.
60%.
That's it. That's all, friends. This is the way how you can refer the chances. 60% of the chance, that means 0.6 is my probability value. Okay, and so why we need, friends, as already mentioned, we can plan ourselves better in uncertain situations. And if it is raining, then we can carry umbrella or finish off outside work today itself. Accordingly, we can plan the orientation. Okay, now if I want to frame what exactly the probability is a measure of likelihood that an event will occur. Probability is quantified as a number between 0 and 1. 0 means, friends,
No occurrence.
no occurrence. One is certain, or else we can say, we can frame like this: 0 means impossibility of occurring, that means not happening or impossibility or whatever the means, and 1 means certainty. So certainly we are going to bring something and definitely it is going to happen. Okay, now I am asking you this example, friends. Okay, so just if you are making use of this particular example, let us try to understand in the example way. So just if you have a look, a classic example, always uh, heading a coin. Okay, so just if you are flipping a coin, chances of getting a head, if I am asking, then how do you say this?
One time.
One time. Okay, because only one occurrence. How many events are there? 2.
2 events are there.
1. Okay, 1 by 2. So maybe Lakshmi is knowing about this probability in her engineering, or because recently. Okay, no problem. Okay, so this is how you can refer this particular example, friends. Okay, so probability of getting these particular head out of the number of occurrences. So just I can say 1 by 2. Okay, so just you can refer the example of that 1 by 2. Probability of getting head equal to 1 by 2. Similarly, tail also. Now, if I am asking you, friends, suppose if I want to get the possible probability of, okay, sum of 2 dice. Dice, someone can help me, friends, to understand what is the how many number of faces we're having in a dice? Basically 6 faces. So the dice you might be knowing. One side, that 1 dot, and in our childhood days we used to roll that particular dice so that we'll be getting some final number. Now here a little bit addition we are doing here, friends. In the earlier example, only 2 possibilities are there, head and tail, so that we could say total number of outcome, total number of happenings are 2, and out of that head is 1 by 2. That is a straight forward narration. A little bit advancement is there in our problem statement here. Let us understand this. Find the probability that the sum of two faces is greater than or equal to 10. Sum of two faces greater than or equal to 10.
Greater than or equal to 10.
When one rolls a pair of dice.
Pair of dice.
Yeah. Okay, so in
4.
One dice, yeah, in one dice we're having 6. For the second dice we're having how many possibilities, friends? 6. So that means 6 into 6 possibilities, na? So total how many? 36. Up to this, is this fine? Any doubts? Because we are rolling dices, there are total 36 chances are there. We always need to observe the totality first, and then out of that particular total we need to capture the specifications. Okay, now how many possible outcomes? That means I want to get I want to get the information, like, you know, which is greater than or equal to 10. Greater than or equal to 10 means, friends, what is the event here?
It should be 11 or 12, or 5 or 6. 5 on 1 dice, 6 on 1 dice. It will be like that. Like because see, 10 means what happens is, if you because you are adding two dice. Okay, 2 dice. So 2 dice should be greater than 10.
Okay. That means probability of sum greater than or equal to 0, greater than or equal to 10. This is our requirement. Okay. And out of this requirement, what we're doing, friends, that means equality is also there. Probability of sum equal to 10 might be there. And then probability of sum equal
greater
to
than 10.
That means 11. And probability of
12. Sum equal to 12.
Because, you know, friends, maybe there is a chance of getting 6 in one die and 6 in another die. This is also 12. Greater than 10. Greater than 10. And maybe one time you may be getting 6 and one time you may be getting, which is acceptable. And maybe 5, 5, which is 10.
And 6 and 4.
Okay. Now, after getting this particular step, my interest is how many possibilities are there to get sum equal to 10? This one we are going to work out. How many possibilities are there, friends, to get sum equal to 10?
2 possibilities.
4, 6.
5, 5.
4, 6. 5, 5.
5, 5.
4.
6, 4.
6, 4. Very good.
3 possibilities.
3 possibilities are there. This is one set. And now let us see the possibility of getting 11.
There's only 2 possibilities: 6, 5 or 5, 6. 5, 6 and 6, 5.
Okay, now friends. Okay, this is the 2 possibilities. Now the third one, friends, actually P of sum equal to 12, because first we have seen the corresponding whatever the experiment we are having. Out of that experiment, our requested interested event is P of sum is greater than or equal to 10. Now we have done with sum equal to 10 and sum equal to 11. Now it is sum equal to 12 means how many?
Only 1.
Only 1. 6, 6. This is 1. Now you, if I am asking you, getting these particular adding all, this is a 3, 2, 1. Total 6 by 36. 1 by 6. How much? Whatever the value we are going to get, that much is required, friends. Okay. So observe here. Only the point is not that much difficult, friends. I can say is a logic actually, because in case of the predictive and descriptive statistics, our interest is just we are having some mean calculation or median. We are not going to do anything, and we are only going to analyze the things. And even in case of the standard deviation variance also, we cannot tamper the appropriate inputs. Okay, because, you know, so just whatever the values I'm having, those particular values are giving a meaning, and we should interlink that particular outcome to the corresponding situation. Suppose if I am saying correlation is 1 between two variables, then what is your understanding, friends? They are correlation. Correlation is between -1 and 1, na? Or what did you say? Covariance we are having, correlation we are having. What is the problem with the covariance? So there is no bound, there is no bounding, and units are also problem. Okay, but whereas in case of the correlation, that relationship you can specify this is between -1 and 1. You can say whether there is a strong relation or weak relation, or there is no relation with 0, those kind of things. So in case of statistics, there is a possibility of concluding the things based on the outcome. But here we are applying our thought process also, friends. Like, okay, we are assuming just a coin has been tossed, and we strongly know that sometimes, just out of this head or tail, maybe the coin is landed on sand or something, and it has not given any head or tail. It is in between actually. Can we take those kind of things also, friends? Maybe if someone is asking you, you are standing upon sand in a beach, and you are just tossing a coin, maybe there is a possibility of fixing this particular coin like this also in the sand. Okay, in that case, I cannot say whether it is head or tail. If it is like this, I can say whether this is head, or if it is like this, I can say this, that's a tail kind of thing. And we are not taking this possibility, because we know that as I am not giving any environment, so automatically I am standing on a floor and tossing the coin. So sometimes, these things are also need to be considered. Whereas in the second example, there are dice, and we should know that dice is having some 6 faces. Okay, and based on these particular 6 faces, my interest here is the summation actually. So dice 1 and dice 2 together, if I am rolling, my interest is how many times I am going to get greater than or equal to 10 possible faces. Okay, so if I am not knowing a dice is having 6 or something like that, there is no chance of conducting this experiment. So that, but maybe we are not implementing these things in our machine learning kind of thing, but to reach that level, because in the subsequent sessions I am going to introduce you conditional probability, which is direct connected with the, just recollect, friends, conditional probability is directly connected with the which theorem, which machine learning algorithm? Venkat, your favorite algorithm? Naive bias, yeah. Because naive bias, which is a conditional probability, definitely we are going to directly apply, use this conditional probability in the naive bias, so as to grab that. And so if at that time, if I'm saying conditional probability, again, we are coming back and making use of all these kind of the conventions. So, and one more important thing is the distributions, maybe normal distribution, Gaussian distribution, Poisson distribution, like that. We're having some 4 or 5 different kinds of the distribution. So that is the essence of this probability. But to reach that particular level, definitely we need to know what do you mean by experiment, and what do you mean by random variable, what exactly the distribution, what do you mean by conditional probability. Okay, like that we are working. Now, one of the important aspect I want to float here, these things are fine, friend. We need not to do any pen and paper kind of the exercise so as to perform the activities. But only the thing is, here certain aspects must be observed. Okay, so those are known as the probability laws. Okay, so just we are having these kind of the concepts, friends, where you can observe some kind of the conventions, like how we are having in statistics all the methodologies and methods. We are having the probability laws. Just if I'm saying union is the first law, and second thing is the intersection, and third one is, friends, complement. Suppose if I'm giving 2 set of data items, And if I'm saying that, okay, this is set 1 and the another is set 2, then how do you refer the union, friends?
A union B.
A union B. If I'm saying this is A and this is B, then how can I shade these, friends?
The middle intersection. Both.
This is the intersection. Both the things I have to specify. Union B means a
Union,
combination of
union is everything it takes
everything
from
it
one
takes.
to everything.
Everything it takes. Okay. Similarly, intersection, a nice thing. Simply the intersective part. Okay, this particular part only I can say the intersection of these things. What do you mean by complement, friends? Actually, any idea?
No idea.
A other than A means out of total minus A.
Venkat is rocking today. So
Rocking?
yeah, of course.
Oh, it's a inverse. Inverse.
Inverse only. So that means
Yeah, got it.
the entire things. That is what you call a complement. Sometimes when it's like this, we are writing or a complement.
That's exactly.
Okay, na? That's all. Okay. So A union B, A intersection B, and as well as A complement. Most important thing, friends, here. Usually, you know, many at times that time our professor used to say mutually exclusive. Maybe you also heard about this thing. From this knowledge, friends, so far we have seen experiment, event, and then outcome, and then we have worked with simple two examples like coin toss, and thereafter we have seen some dice. Okay, now we are come across with union, intersection, and as well as the complement the things. What do you mean by mutually exclusive?
It doesn't belong to both of.
Very simple thing. That's what, Venkat. A, B are there, and that particular outcome is not at all belongs to the AB. Now, can you talk in terms of union or intersection, Venkat? Just you think through. You are right. Nothing belongs to A and B. How can I frame your words into the statement of the probability? This question is for all, friends. You can also take a chance and you can give. Probably Lakshmi can do that. Yeah.
A union B, complement of A union B.
Complement of A union B is nothing but nothing is there common means what, friends? A intersection B must be. Zero or null. That means observe here. Okay. So at the moment I am saying my A value is 1, 2, 3. My B value is 4, 5, 6. If I am asking you to compute A intersection B, obviously nothing is there, no, friends, common. So 0, or you can say null. Now, if this particular probability of A intersection B is 0, then I can say A and B are disjoint. What do you mean by disjoint, friend, by the way? My internet is working. Oh, yeah. Hope my audio is clear. That means, friends, what do you mean by this thing? A intersection, A and B are disjoint means there is no common. Far away. Okay, no common in between these two. Okay, that I can say as a disjoint. Okay, so like a union, we are having some elements. Intersection is something different, friend, which is common to these two kind of the sets. Then I can say the intersection. Mutually exclusive or disjoint just specifies that at the moment I am trying to get the intersective path between A and B, and if that it is giving 0 or null kind of the aspects, then I can say those kind of things are mutually exclusive or disjoint kind of aspects. Okay, got it, friends? Yeah. Now I'm asking you, if I am making A intersection A complement, what is the output? I'm having total 1, 2, 3,
Universe missing.
4, 5, 6. A is equal to 2, 4. I'm having. This is also
0.
0 because see, A is 2, 4 here. What do you mean by A complement? Okay, na? Because out of this A, I am computing the A complement. Now I am trying to get the A intersection A complement, which is null. Hope you got the point, friends. Okay, this is how you can refer the mutually exclusive. Now observe here. So just I am having probability lies between friends
0 and 1.
1, 0 and 1. This is the standard fact we know. Now if I am saying this point, probability of A equal to 1 minus probability of A complement. This is of course first property. Second property is nothing but how do you analyze this, friends? Probability of A plus probability of A bar. What do you mean by that, friends?
Is 1.
1, because both the probabilities. Now at the moment you are saying some probability of A equal to 1 minus probability of A bar. This is understood. Okay. And coming to the next one, if I am saying this third property, probability of A union B. Be with me, friends. I need your utmost attention. Simple formulas only, these things. Probability of A plus probability of B. Can someone help me? Minus?
A intersection B.
Excellent. Okay. So these properties, okay, these are all nothing but the three properties of the probability. What is the first property, friends? Probability lies between 0 and 1. We pretty know that. And if our answer is in the interview panel, if you say probability is 2 and probability 3, you need not expect any second round of interview for the data scientist job, unless otherwise, even in that panel also the members are not aware of statistics or probability. Definitely there are chances to get the second round of the call. This is the first basis information. Second thing is probability of A equal to 1 minus probability of A complement. Probability of A is the set of elements, of course, whatever the values we're having. The complement 1 minus probability of A dash is nothing but probability of A. The third important thing, okay, the third important thing is probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. What it refers, friends? Suppose diagrammatically, if I am asking you this question, I'm having A and as well as the B. Okay, now how you analyze this A union B, friends? Actually, A union B is nothing but all the things, na?
All the shared everything. Yeah, that's it.
Why you are deducting this one? Can someone analyze that part, friends? Minus probability of A intersection B. Why we have removed this part, friends?
It's already repeating, you know.
Excellent, excellent. We are avoiding the repeat. Nothing we are doing, only avoiding the repetition. See here, probability of A we are referring, we are adding that thing with the probability of B, and we are simply, see, in A we are adding this one, in B also we are adding this one. So as to avoid that repetition, just you can deduct this thing.
That is a characteristic of union actually. Union doesn't
Correctness
take
of the yeah.
union doesn't take repeating. Union all will take repeating, but
Exactly.
union cannot take.
Yeah, man. That is how you can connect your concepts with the technical aspects. So union, in case of SQL, you pretty know, even Hive also, that union gives that some kind of non-repetitive values. But at times, you know, you want to specify your your repetitions as it is. Never mind. In that particular case, you can have a look of that thing. Okay. So these three are the specifications where you can refer the probability laws or probability properties. Most important thing, friends, conditional probability. Okay. Can someone analyze probability? We have seen is a kind of experimentation which is giving some outcome, and after that outcome we can consolidate. So this is my outcome, so that I can plan accordingly. Now, how did you observe the conditional probability? We are adding condition also to the probability. Then what is your thought process on this, friends?
In this, if suppose if I am tossing a coin, that we have an additional condition. What is, like, if the head comes, then some other activity, it's like linked.
Yes. See, exactly. Linked aspect. He has told, that's our friend is telling. Pre-qualified condition. See here, conditional probability remains same, friends. Don't worry about that. That we are very clear is uncertain kind of thing, where we are having some event, I mean experimentation, and as well as the event and outcome we are having. Now outcome depends on some pre-qualified condition. That means this time I'm not leaving my probability entirely. Rather, what I'm doing is just I'm linking, as our friend told, linkage is there between tossing a coin or performing some activity. It is guided by the pre-qualified condition. Such kind of the thing is known as the conditional probability, friends. So outcome depends on some kind of the pre-qualified thing. Now, how do you write that particular thing? Okay, so that means P of
You can tell,
I'll take that. I'll take that. P of A given B. Okay, this how I am saying is P of A given B. That means P of A given B. That means probability of event A happens given that event B has already happened. Okay, so happening of A depends on B. Happening of A depends on B. Let us take some example. Let us take some example. Suppose I'm having some kind of the number of balls. A simple example, friends, a textbook example kind of thing where you can refer. I'm having some kind of a blue and red balls related to some kind of the number. Just to have a look on this. And this particular thing gives me, in a bag. So just I'm having some blue colored ball, blue with the number 1, and same blue colored ball with another number, same number 1, and red colored ball with 2. Okay, that means a bag has 3 balls, 2 blue balls and 1 red ball, and red ball is numbered as 2, and blue ball is also numbered as 1, 1. Total 3 balls I'm having. Now, if I want to get the probability, that means if I'm writing this one, friends, what is the possibility? I'm not discussing about the color. I'm only focusing on the number should be 1. Total, how many aspects are there which are belonging to number 1?
2.
And how many ways I can get? 2 by 2, because only 2 are there. Number equal to 1, I am saying. Okay, 2 numbers are there. There are possibilities of those kind of things, but slightly modification I'm doing, friends. If I am saying like this, my number equal to 1, given that, okay, my number equal to 1, given that this ball equal to blue, if I am saying. Now, just to think through, friend, don't be in a hurry to give the wrong answer.
1 by 2.
That means the ball must be blue now first.
Only 1 ball is there which is blue.
No,
Or
2
2
balls
balls
are
is
there.
there.
2 balls are belongs to that one, 2 or 3, 2 balls. And just if I am saying that number equal to 1, that means out of these two, how many balls are having number 1, friends?
2 by 3 answer is actually 2 balls.
Both number equal to 1, Suresh, and
No,
ball
number
equal to
1
2.
is 2 balls. 2 by 2. Yeah,
This is out of range.
Sorry.
This is out of range. And
Out of
that is what, friend. A simple logic is there. Though we are having the experiment as blue, comma 1, blue, comma 1, and red, comma 2. But our interest is there is a condition actually. What is the condition? What is the condition here? Condition is that ball must be blue. Though I am expecting number equal to 1, but my intention, my condition before selecting that number as 1, if that particular ball equal to blue, then only I am interested to get and pick up the ball. So total 2 this particular blue balls were there, okay, and with numbering 1 and 1, and of course my interest is also 1. So that means 2 by 2, where the probability equal to 1, outcome is 1. Suppose that if I am refining my statement like this, friends, number equal to 2 and my required color of the ball equal to blue, then can someone help me, friends?
Like null, 0.
0, because the condition here is ball must be blue, and correspondingly I don't have any colored ball. This is 0. Like that you can analyze. Nothing is there, friends. Can someone differentiate what is the probability and what do you mean by conditional probability?
Conditional probability, you are digging more and you are making people easy to get a value.
That
In
is
a prediction is more easy. It will be more easy. The value.
that is a way of understanding, friends, actually, to be frank. See, at the moment we are going to introduce some more terms. It doesn't mean that we are going to enter into the complex zone, at least in data science terminology I am speaking. If I am saying decision tree, and later if I am saying a revision of the decision tree is the random forest, that is not the complex thing, friend, but that is a simplification of and more powerful than the decision tree. That is the most important point. Okay, so here the point is can you okay, this is easy and more I can say more chances of getting into the required thing by putting up the condition. But apart from that, what is the differentiation between probability and conditional probability, and which one we can depend more, friends, just to think through and give the which is playing a significant role in our machine learning or data science scenarios?
Conditional probability makes a significant role because it takes you near to the more near to the answer actually.
More near to the answer, and it is avoiding, it is cutting down, and it is pruning all the possibilities. If my
because you are going with the theorems of that, all the probability theorems with the conditions, applying conditions on that.
Okay.
That is a given a sweet to somebody like a sugar patient.
Okay, so that means, friends, here probability in the sense which is exploring more actually, like I need to consider more possibilities and all, so that we can have a look on that. But conditional probability is greatly helping us so as to prune the steps in such a way that just we are putting up some condition before applying the probability. That is how you can specify the kind of conditional probability. Okay, now one more thing, friends. Suppose if I am not verifying any condition and I want to get some kind of event occurring, can I say that as a conditional probability? Like let me revise the question like this. Let me take this example as it is. This example I'm taking as it is, friends. Now what I'm doing is just I'm saying you to already have given P of number equal to 1. P of number equal to 1. If I am saying individually, without any possibility, I have not mentioned any blue or red colored ball or nothing. I am not mentioning. This is a pure probability. Probability of number equal to 1. Then what is your answer, friends? Don't think through, because this context is I am talking about the conditional probability.
It is 2 by 3.
Excellent. Because total how many balls we're having? 3. I mean numbers at least. Okay, so the total balls, because here no condition is playing a role, each and every one we are considering as one kind of event. Event 1, event 2, event 3. That means total event occurrence is 3. Out of that, what I am saying, then I am applying some kind of thing. 1 and as well as 1. So 2 members were there. And if such is the case, then I can say that as a marginal probability. Can someone help me, friends, to get the understanding of marginal probability? Marginal probability is the probability of an event without reference to any other event. Okay, so just I'm having some probability of event without referring or without depending on any other event. Okay, so just we're having some event and without referring or without depending on any other event, just we are getting some kind of the outcome. That is what you call the marginal probability. Now you tell me, friends, what is the difference between probability and marginal probability?
It's a basic one, marginal probability.
Basic one. So that can I say probability and marginal probability are equal, or?
Yeah.
Exactly, they both are same.
Both are same. That means the member, suppose if I am not introducing you the concept of the conditional probability, then I can say marginal probability equal to probability. After introducing the conditional probability to you guys, can I say marginal equal to normal probability?
In a conditional property, remove a condition, that is a marginal property.
That's all.
Probability.
Removing or not considering any condition, okay, then I can say marginal. There is a significance, friends, actually. Though we are having like this data science skills in ActionSure and machine learning skills in ActionSure, again data science skills in TCS. Now if I am particular about the company without knowing the skill, can I say that as a marginal from this example? Or else let me give you this clarity. ActionSure, ActionSure and ActionSure. Now you tell me, if I want to get only data science skill set or ML skill set or AWS skill set, what is the context of this thing? And what is the context of getting data science skill set here? Which is a marginal, which is a normal probability? Can I say the second scenario as marginal, friends? Can I? Second one, can I say any? This is a normal probability, na? This is a probability. No, I cannot say normal also. This is a probability of getting the members in the context of data science, machine learning, and AWS. But in the first context, though I am having the reference of the companies, but my interest is on the data science orientation or ML orientation. I am excusing something, friends, here. Or else I'm ignoring something, or I'm not giving any priority or weightage to those particular company names. So in that case, I can say this as a marginal one.
Okay, it is like getting ahead, something like that, correct? No, event, data science. I want only.
Yeah, of course. Getting data science profiles, no matter whether Accenture or TCS, maybe collaboratively IBM is doing some kind of the venture with Infosys, Accenture, and TCS. They want to integrate different members, okay, from Accenture, TCS, and Infosys. And IBM is the, I can say, as a coordinator. IBM acting as a coordinator, and they want to promote. IBM is doing some kind of with some companies like Stackroot, NIIT, and as well as Great Learning, because there are all some training platforms would be there, and they're having this proposal like, you know, picking up different categories of the people and train them. Okay, so in that case, only they want to take up that data science kind of the profile. And you may ask me what they get if they do. Then IBM, for IBM people, these Accenture guys need to provide the training in their strengths, like maybe mainframes or whichever. So it's a mutual kind of thing, friends. Okay, so yeah.
It is more like it is like I want an king in the deck of cards. It doesn't matter whether it's like spade or whatever it is. I am only concentrated on taking the king. So I will not calculate all other possibilities of whatever. Only I'm interested in the king, getting the card which is king. That is marginal probability.
Marginal, okay.
If I am
repeat once again, Venkat. I lost this thing. Marginal property. What example you are giving? Probability.
No. I am saying, see, marginal is like with the example of data science, like Accenture is doing, TCS is doing. We are only interested in data science. That is Accenture and TCS. So here I am saying, I want an the king in the deck of cards. It can be a spade or whatever the other symbols like art or whatever the other two. I'm not interested in. So I'll only calculate for that particular thing instead of calculating everything.
So if you say, in a card's point of view, if I say that I want ace, all the aces of the card, then will you say it is a marginal probability?
Yeah, go ahead, friend, discuss. Because that is a valid point, actually.
All the aces, I'm not specifying any ace. I'm not saying that it is a spade or a diamond or a heart or a club.
If you are adding that constraint, then only it comes to the marginal, Venkat. If you are roughly saying, see, and that too,
get into the concept properly.
And that too, yes, if you are picking, that is never become a marginal probability. That is a probability. That's all. Probability of getting yes. Probability of getting yes. That's it. If, as our friend told, maybe that is a diamond or some kind of categorization is there. Na? Again, you are making use of the digging into the model or category. Then only your marginal is coming into the picture. If your thought process is only revolving around only one point, you need not worry about the marginal probability. Marginal probability comes into the picture whenever there is a granularity existing. Whenever there is a such granular. Got it, Venkat.
I'm thinking about conditional, then it should be a diamond.
Again, association. That association.
Now, when you put a spade or a club or a diamond or this thing, it is a condition.
Definitely marginal. You can say it's a marginal. Okay, in that case, only you want to pick up some diamond, or only you want to pick up some kind of you are making some other granular level. Okay, then it is becoming conditional probability. And though you are referencing, and if you are not, especially that ACE example, we cannot fix up in the context of the marginal probability. That is for sure. But because Accenture, TCS, and Infosys, and they are working on data science, Definitely you can say, because many companies are there, but still they are talking about the data science. There is a context. There is a contextual differentiation. Okay, that's it. Now coming to this properties, friends. Actually, in case of earlier discussion, we have seen 0 to 1, probability of A equal to 1 minus probability of A bar, and probability of A and B equal to probability of A plus B minus A intersection B. Those things we have seen. Now have a look on this. Observe here. This A given B, actually, that's what this is, not A by B, friends. In case of conditional probability, the notation is like this: probability of A given B. That means this is probability of A given B, or probability of B given A. This is probability of B given A. Now you observe here some of the properties. If I want to get probability of A given B, this means if B happens, then only I'm going to get the A is going to happen. Now A should depend on what, friends? Actually, A should depend on B, whether B is going to happen or not. That is nothing but probability of A intersection B given B. Okay, so that A intersection B, A is completely dependent on this thing, so that we are expecting B is going to happen. Now probability of B given A. If you observe this particular standpoint, probability of A intersection B by probability of A, then I can say that is a, after A is happening, then only I can say that my B is going to happen. Now you tell me this point, guys. Can I say probability of A given B is equal to probability of B given A? Can
no,
I?
no, there is a
No,
difference.
no. Any other obligations?
For example, if you take the same dice, dice one,
Mm.
you said that you want greater than equal to 10.
Mm.
Okay, so we got 6 out of 36. Now in
Correct.
that, if I take P B of A, then it should be, actually they take that example, it should be equal. If I don't know, or I'm wrong. My
Yeah, exactly.
anticipation.
Exactly. See, if you are taking such kind of the examples, mutual exclusive is not zero, friends. They're having some kind of the equalities, and maybe we are not naming this is dice one and dice two kind of aspect. In that case, you can think through the equality, but here the point is, if probability of A equal to B, then you are correct. Probability of A equal to probability of B. There is a small convention. Probability of A is equal to probability of B. Then I can say this given
Okay,
probability of
okay,
equal
yeah.
to B.
Probability.
Prob-
I think
Ah,
I was looking at probability based
there
on
is
probability
a
of
there
B.
is a specific condition, but now the
Correct.
point here is, because there is a chance of, if that is the case, then would have taken some other zoner, but here in, especially in conditional probability, friends, probability of A intersection B by probability of B, make sure that A given B, because after happening of this particular B, then only we are going to get the essence of this A. That is the first point. Second important thing is, if I am making use of this my probability of B given A, so in that particular case, we are making use of probability of A intersection B by probability of A. So there is no chance of occurring this particular probability of A given B, which is not equal to probability of B given A. Okay, so this is what I want to discuss in this session, friends. And just can
I still
someone help
want to
me?
go with the example. I'll try out Uma.
Please.
I'm contradicting you on probability of A on B is equal to. Let me just check it out. I want to do it by myself. I mean, I'm not challenging you, no way.
No. Okay, it's okay. No problem. Because,
because
friends.
when I'm looking at the die example,
No.
it's showing that both the things are, it should be same. The way you have the condition greater than equal to 10, you have given that example. So there, if I calculate, if I take the formula of probability of A on B,
Mm. You have to frame
now
the question. Just to frame the question in that case, how do you frame the question here? Earlier I asked what I asked, greater than or equal to 10 together. Some
Correct.
actually I have asked. Now can you frame some question? What is the question you want to frame? Because you need to
I
put the
don't.
condition also. You have to put the condition also. Ah.
I'm not taking sum. I'm just looking at
Ah.
what are the possibilities of getting greater than equal to 10 on the 2 dice.
Okay.
Okay, if you are going with greater than equal to 2 dice, now what you're telling is probability of A. So one die will get 3 options.
3. Yeah, of course. We have seen that. Okay. That means initially greater than maybe equal to 10. Okay, we can get 5, 5 and 4,
5,
6,
6, 4,
6,
6.
4. These
4.
10 equal to, yeah. 11 means 2, we got 5, 6 and 6, 5. 12 means only 1. Okay. Then
Now, if you go to the second side, probability of B on A, then also you'll get the same answer.
yeah, see, here the point is on what condition we are taking. Condition should be there, na? Because here we have never mentioned any condition. Only we are seeing we are giving equal importance for both dice 1 and dice 2. So there is no question of taking the condition here. Maybe you can say greater than or equal to is a condition. No, this is a probability of getting greater than or equal to 10 chances. These are all.
A better example is the balls. We talked about two.
Definitely a better example, that is
ball. What is the condition of taking the what is the probability of picking a blue ball first, and then the second is like a red ball? So might be that will work out. Suresh, if like what Uma said, the probability of A is equal to B, then all
no
this
question of yeah no
B, then
Tell
this
me, Venkat,
not happening.
Tell me this statement. Can you just explain the statement once again? Uma, can you just go up?
Where is this one? Condition
Yeah,
probability.
the first one. You explain the statement, Venkat.
Probability of A given B equal to probability of A intersection B by probability of B. If B is, happen, if B happened, then only A is
now
going
what
to
is probability of the first one? Let's just probability of A given B. What do you mean by that?
Suresh, one thing.
B is a condition. B is a condition.
B is a condition.
A and B is equal to 1. 1 is a probability. You know, if one is happening 30%, the other will happen 70%. Then
that is a pure probability.
If it is like 50-50, then whatever you do, A or B or B or
same. And that too, as our Venkat is rightly saying, for the dice example, we are not at all pulling these conditions. Only the thing is dice 1 and dice 2, we are giving equal importance. They are equally prioritized.
We are actually, in the die example, we are going in generic.
In generic,
yeah.
But whereas in ball example, Suresh, you know, ball comma itself, the problem statement itself is having some.
I understood. I understood.
Okay.
I understood. I'm
no
sorry. Don't bother.
No,
Venkat, I want things to be on a proper, understanding should be really important.
Yeah,
no, that's correct. That's
Suresh,
correct.
Definitely, we are
That's the reason there is the question. Don't bother. Don't mind anybody.
See, my thing is 0 and 1. 0, either it will be 0 or 1. If it is like 50-50, all this
Venkat, that should be the gunshot. Venkat, in probability, that should be the gunshot. If you are thinking, it's gone. The model is gone.
No, that's important. That's important that we get all. See,
that's what I want you to get gunshot. I got it actually.
It was like very complicated at the time. When we go deeper, you're picking some balls from the box or from a closed bag, and you pick out of 10 balls, you pick the first ball, then the 9 will be remaining, and when you are picking the second ball, it will be like 8. From 8 we need to calculate the probability. Like if a small mistake we do, everything will go.
That's everything is going. It will wash out everything. Total washout. That gunshot should be there in probability. There should not be any, he hicks and you should not waver your arm. I mean,
Okay.
sorry, Uma, and sorry,
No,
Venkat.
no, no, not like that. Not like
Hey,
Not
that.
to not to
that's
degrade you or anywhere.
important, you know.
I
That's
want
it.
you to gunshot the answer. That's what I raised the question.
That's important that we discuss. Otherwise, we have done in the college, but when it comes here, we have to recollect all those things. Now,
Exactly.
the discussions, we either I am wrong, or sometimes you are wrong, or sometimes we get all those by discussion. You know.
That's it. That's
Because
it.
I felt, Venkat, you were wavering your hand. That's what I raised the question. Because I want you to understand, then the whole class will definitely understand.
Okay.
I understood because I taught my son in the 10th class, first term. So it was like gunshot for me, like probably.
Very good. Okay.
As
So
a 10th
just if
class
you
boy.
are referencing the key takeaways of the session, we started with some kind of the terminology, friends: experiment, outcome, and as well as the event. Basically, probability is the uncertainty. And if I want to make use of that particular uncertainty as a chance of getting some insight, then I can go with the probability. And we are having certain properties related to that probability. Just we have seen union, intersection, and complement, and mutual exclusion kind of thing. And union, intersection, and complement, they are straightforward, like getting A union B, A intersection B, A complement, these are fine. Mutual exclusion, what it says is your intersection part must be null or zero, then I can say that is a mutual exclusion or disjoint kind of the set. And then we have taken the understanding of this conditional probability. Compared with the normal probability, conditional probability is a bit distinct. Reason is simple. The conditional probability makes sure that before happening any of the event, it is connected or it is linked with some other event. If the X event is going to happen, then only I am going to get the Y event. How can I write that? P of Y given X. That means X is happening, and then only if X happened, then only Y is going to happen. So for that particular case, we have taken some kind of the properties like, probability of Y given X equal to probability of Y intersection X by probability of X, like that we have taken. And probability of X given Y is equal to probability of Y intersection X or X intersection Y by probability of Y. Okay, these things we have observed. And there is one more important thing we have seen: the marginal probability. What do you mean by this, friends? The marginal probability is nothing but without any condition, though there are some chances of embedding the condition, like blue comma 1, red comma 2, blue comma 2, like that some kind of the conditions would be there, but we are not interested to pull those particular conditions. We are going to apply some kind of the without any condition. If you are picking up the probability, even though there is a possibility of establishing the condition, such kind of the things can be known as the marginal probability. Okay, this is what you can refer how we are going into the probability and as well as conditional probability. In the next session, friends, we'll see some other aspects related to the conditional probability. And thereafter, most excited part of our probability journey is the distributions. Okay, because that greatly helps us to understand the data and to follow up the kind of the relationships exist in the data. All these things are there. Okay, that's all, guys. That's all for today's session. If you're having any doubts, please let me know. Otherwise, we can wind up the session.
Very interesting.
Okay.
Now, one thing, Uma.
Yeah.
In conditional probability,
Ah.
these two are simultaneously it is going on, no? Because X is already going up, then Y is coming on that.
No. These are all two properties. Maybe you are interested in Y given X. Why we are saying this is here our intention is sometimes as together I am saying to, because these are all two
Is
properties.
both events happening at the same time?
No, never. Okay, so only the thing is X given Y. Okay, so just is not equal to Y given X. To exploit that point, I have shown you the two properties. Okay. Right. Hope you got the point.
I got the point.
Here we have only two things. One is Y of X and X of Y. So if I get Y of X as 0.3, then X of Y will be 0.7. I think there will be more than 2 or 3, A, B, C, like that, correct?
Many would be there, but only the thing
Many
is,
would be there. Many would be
A
there.
given B, B given C, like that. If is there, then the chain will go off, friends. Actually, so
calculate all those.
actually, if you observe your Bayes theorem, then you have to do that only. Like all the contributors would be there, like all the features we are there, and we are giving equal importance to that. Maybe given X, given Y, given Z, given A, given B, like that many are there. We are integrating, or we are intersecting all those particular weak learners so as to generate our naive bias. And how much you are digging into the conditional probability, that leads to the destination of Bayes theorem understanding, friends.
Exactly. The conditional probability is the most important here.
Important thing related to the Bayes theorem. Yeah.
In jobs, once long back before I've started data science, they ask for this Bayesian
classification, Bayesian classification. Yeah.
Knowledge about Bayesian classification.
Yeah, Bayes theorem and Bayesian classification, naive bias. These are all three we are going to make use of in our implementation. Okay, so don't worry, friends. Hardly this week and next week middle, we are going to have these probability understanding also. Then one day we'll fetch all these 1 or 2 days. Just we'll go through all the 30 or 32 sessions flavor or just summary kind of thing. And then is a straight narration. Next thing, what is the algorithm? What is the stat behind that? And implementation, understanding of the results. Okay, that is very simple thing. That's it. Okay, guys. Go ahead.
Today only I was thinking about this, having that revision. Might be if all the people are agreeing, we'll talk about some topic so that we'll also will prepare and we can
give you some kind of that I will do, guys. We'll do, guys.
Regression or assumptions in
regression.
I can prepare and I can talk. So I'll also have an experience of talking, so I can do good in interview, and also other people can understand where I'm.
You are talking more.
Talking more is different with talking over.